In 3.5, we're going to find absolute maximums and absolute minimums. So I'm going to remind you in Objective 1, we talked about the extreme value theorem. Which guaranteed us that a continuous function on a closed interval will have an absolute max and an absolute min. All right, so let's look at examples and find out where these values occur. So here we have a closed interval from a to b for a piece of a function. I can see that I have a lowest value and a highest value overall. So, this is a, this will be f of a, b, and up here f of b. So f of a is the lowest y value, so it is the absolute minimum. F of b is the highest y value, so it is the absolute maximum. It's really important to know there's two things you could be asked. Identify where they occur. So the absolute minimum occurs when x is a. The absolute maximum occurs when x is b. Or you might be asked, what is the absolute min? What is the absolute max? Y values are absolute mins and maxes. So f of a is the absolute minimum, and f of b is the absolute maximum. So let's look at one more example. So another closed interval, a to b. This time, though, the endpoints are not the highest or lowest points overall. My highest points are somewhere in between. We call these values our relative max and our relative min, but notice on a closed interval, that is the highest value overall, and this is the lowest value overall. So let's call these C, D. So in this case, f of C is the absolute max, and f of D is the absolute min. What we're trying to see here between the two examples is where these values can occur. So in the first case, they occur at the endpoints of the closed interval. In the second example, they occur at the relative max and min, or the critical numbers of our function. So those are the two possible cases that we have. So the absolute extrema can occur at the endpoint of the interval, or at the critical numbers of the interval. So you do want to watch out for any values that are not within your interval. So whatever a to b is, make sure you're staying within that interval there. So let's look at a few examples. All right, find the absolute extrema for each function. We'll do a couple examples of this. So here is example 1. F of x is 3x to the 4th minus 4x cubed. We're on the interval -1, 2. We do have to make sure that we stay within that interval. All right, so 2 things we have to do. We need to test our endpoints versus our critical numbers. So on the side here, we're going to set up our candidates test. So see who's in the running for absolute max and min. This is our candidates test. Okay, so again, there's the 2 categories. There's the endpoints and the critical numbers. Now the endpoints, we already know. The endpoints are -1 and 2. So we have to test these values. So we're looking for the highest y value and the lowest y value. So I need to find f of -1 and f of 2. These just go right back in to the original function. So f of -1 is going to give us 3 plus 4. So I have 7. And f of 2 is going to give us 48 minus 32, which is 16. So far, 16 is my highest value, so it's possible this is our absolute maximum. But we'll have to compare it to the critical numbers of the function. So we need to go back and find our critical numbers. So we'll do our first derivative test. Note that it is a polynomial, so it is differentiable everywhere, so we don't need any of those values. We only need the zeros of our derivative. All right, factoring here. So I do get 0 and 1. What you want to make sure you do with the critical numbers is double check that they're within the interval -1 to 2. If any critical number is outside of the interval, you're not going to test it. Because again, we're only interested in the values that are within our interval. So 0 is within the interval, 1 is within the interval. So we are going to test both values. So 0 and 1 both get plugged into the function. F of 0 is 0. If I plug in 1, we get 3 minus 4 is -1. So I'm looking at my y values, all of my outputs. Okay, which of these values is the largest? Well, that's 16. So 16 is the absolute maximum of the function. Where does it occur? It occurs when x is 2, so at an endpoint. What's the absolute minimum? So the smallest y value between the remaining 3, -1. -1 is the absolute minimum. Where does it occur? When x is 1, so at one of my critical numbers. Okay. We're going to write that out. Absolute max is 16. The absolute min is -1. So again, when you're asked to find the absolute max and min, your answer is the y value, not the x value. You want to know what it is, not where it occurred. So let's try another problem. We have sine pi x. Now sine is a continuous function for all reals, so we are going to be dealing on a closed interval, 0 to 2. So those are my endpoints that I do need to test. Endpoint, we're going to do f of 0 and f of 2. So plugging 0 into our function, sine of 0 is 0. And plugging in 2, we get sine of 2 pi, also 0. pi. So let's go ahead and find our critical numbers. Sine is always nice, smooth, continuous function, so it is differentiable everywhere. So we're not going to have any critical numbers from that. We're just going to find the zeros of the derivative. Derivative of sine, we start with cosine. We leave the insides alone. This is chain rule here. Okay, so derivative of sine is cosine. The derivative of pi x times pi. We set it equal to 0. Now the coefficient pi is not going to affect this, so we're not going to worry about that. But we do need to find where cosine pi x is equal to 0. So we're going to start with the cosine of what angles make 0. So 1 is cosine 0. So cosine is 0 at pi over 2, 3 pi over 2, 5 pi over 2, also my negative pi over 2, negative 3 pi over 2, and so on. So let's go ahead and solve for x here. We're going to divide by pi everywhere. We get 1/2, 3 halves, 5 halves, 7 halves, and so on. But I only want to keep the values that are within my interval here. So that's only going to be 1/2 and 3 halves. So those are my critical numbers to test. Plugging in 1/2 to our function, we get sine of pi over 2, and sine of pi over 2 is 1. Sine of 3 pi over 2 is negative 1. So comparing my y values, the largest is 1. The smallest is negative 1. So we have the absolute maximum is 1. Absolute minimum is negative 1. One more example. Number 3, f of x is x minus 2 over x plus 1, and we're on the interval 0 to 2. So for our candidates test, our endpoints 0 and 2 get plugged in. So f of 0 and f of 2, so endpoint. So f of 0, we get negative 2 over 1 is negative 2. F of 2, we get 0 over 3 is 0. We're going to move on and look for our critical numbers of the function. So anywhere where the function doesn't exist, yes, x equals negative 1 is a critical number. However, it's not within my interval, so I'm not going to test it. Then I also need zeros of my first derivative. So we're going to do a little quotient rule here. Okay, we'll simplify that. X minus x is 0, and 1 plus 2 is 3. We would then set this equal to 0. You'll notice the only way a fraction makes 0 is if the numerator is 0. The numerator is always 3, and so this will never equal 0. So we have no critical numbers to test against. Since the only critical number of the function is negative 1, and it's not in our interval, then all we care about are these two values here. So the biggest of these values is 0, and the smallest, negative 2. So we'll say absolute max is 0, and the absolute minimum is negative 2. And that finishes up our examples for this lesson.